yesterday, you guys, we talked about division or multiplication of fractions. Today we're going to be talking about division of fractions. So please write the title, make sure it's in your table of contents. Now, when you're talking about division of fractions, you're not writing this down, I just want you focused up front. So put your pencils down. When you think about division, if I take 8 and I want to divide that by 2, basically what this is asking is how many groups of 2 can I make from 8? So if I take 8 of anything, how many groups of 2 can I make? So here's a group of 2, here's a group of 2, here's a group of 2, and here's a group of 2. So it's really how many groups of 2 are in 8? Okay. So you're taking a number and splitting it into equal groups. The key word there is equal. Now, when you come to, if I had 9 divided by 2, and I had 1 extra, I can't take a 1 and put it into a group of 2. So that's why there would be a remainder. Remainder is how many are left. So that's looking at division with whole numbers. Now, when you talk about division with fractions, though, let's say I took that 8 and I divided it by 1/2.
That's still 4.
This is saying how many halves are in 8. So now, if I draw 8, and I say how many halves are in 8, well, in this first one, how many halves are in it?
1, 2.
And how many halves are in it?
2, 2, 2.
Okay, so here,
2, 2.
this equals 16 halves, right?
Yeah.
So when you're looking at dividing a whole number into a fraction, it's not that hard because I take the wholes and I divide them by the fraction. If this was 8 divided by 3/4,
But that would be 24.
if this was 8 divided by 3/4, so here, if I drew 8, that's 1. And what I'm going to do is I'm just going to clone it to make it go faster. So clone. Oops, clone. So that's 2, that's 3, clone, that's 4. So there's 4. Now clone the whole thing, and that's 8, right? So here I'm dividing it into fourths, right?
But can only color it in 3.
But now, so I have 1/4, 2/4, 3/4. That's 1. I have 1/4, 2/4, 3/4. That's 2. 1/4, 2/4, 3/4. That's 3. 1, 2, 3. There's 4. 1, 2, 3. There's 5. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, and I'm left with a half left over, right? So here is 1, and then it's 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 10 3/4 with a half left over.
So it would be 10 and a half.
Mm-hmm. Now, last year, you guys, is when you first started with division of fractions. So last year is when you started with division of fractions. And you know, and I'm pretty sure your teacher last year taught you a cute little trick, right? So if I take 2 fractions, such as 2/3, and I want to divide it by 1/4, this becomes a little more difficult to draw like I was doing with a whole number. Because this is saying how many 1/4 are in 2/3. So your teacher last year, I'm pretty sure, taught you, everybody needs a little KF, right? Remember that?
No.
Keep it, change it, flip it, right? Change, flip. So this stays the same. This goes to multiplication. This, you flip it upside down to get 4 over 1.
How'd you get
I just divide.
How'd you get what? Oh, now I understand how you got it.
Oh, okay.
I did the algorithm.
Oh, I was like,
Please stop talking.
It's 8 divided by 2.
Your back is not to me, ever, when I'm teaching. Turn your chair and face forward. However, the Common Core doesn't want to know if you know this little simple trick. The Common Core needs you to understand what's really going on with dividing fractions. Okay? That's what the Common Core wants. So when you're looking at this, and I'm going to ask you to draw, like yesterday when we drew the multiplication, right? Drawing multiplication is easy. If I have 2/3 times 1/3, I basically look at it, and on this side, I'm going to put 2/3. So I'm going to split it into thirds, right? And then on this side, I'm going to take 1/3, and I'm going to split this into thirds. So here, I'm going to color in 2 of them. Here, I'm going to color in 1 of them. And then all I'm going to do is I'm going to then just lay them on top of each other. And I have 1, 2 that are colored both, but I have how many? I have 9 altogether, right? So my answer becomes 2/9. But division isn't multiplication, so it's going to be a little bit more difficult, right? This is how many, if I'm using division, this is how many 1/4 are in 2/3. Okay, so I'm going to show you something in just a minute. That is going to make it very simple as long as you focus. But let's take some notes first, just to review what division of fractions is. When you're talking about division of fractions, your very first step is you have to convert improper fractions or mixed numbers to improper fractions. So let's look at the problem. 1 2/3 divided by 3/4. So the first step is I'm going to convert any mixed number into an improper fraction. So 1 times 3 is 3. 3 plus 2 is 5. Denominator stays the same. And then it's divided by 3/4. So it's 5/3 divided by 3/4. That's the first step.
And then you would change it.
Okay, step number 2. You're going to rewrite the dividend, the first number.
What?
The dividend is called the first number. Change the division sign to a multiplication sign, then convert the divisor, the second number, to its reciprocal. So you are going to multiply by the reciprocal. And again, that's where it's, KCF, right? Keep it, change it, flip it. Everybody, change, flip. Right?
No.
No.
It was like a little
So you're going to rewrite the dividend. The first number in a division problem is called the dividend. You're going to rewrite it. So here, I'm just going to take my 5/3 and I'm going to just write it. I'm then going to take my division sign and change it to multiplication. And then I'm going to use the reciprocal, which I just take my 3/4 and flip it upside down. So the numerator becomes the denominator becomes the numerator. So the 4 goes on top, and the 3 goes on the bottom. It's very simple.
It's not going ahead.
Why are the two numbers, four so good?
Academically. Right, that's what it's really called. I'll move it up just a little bit. Okay, then step number 3. Is you're going to multiply the fractions just like yesterday. So if you don't remember what to do to multiply fractions, see your notes from yesterday. You multiply the numerators, you multiply the denominators, then you rename and reduce. So here I have 5/3 times 4/3. I multiply across and I multiply across. So this makes 20/9. Now 20/9 is an improper fraction, so I need to convert it back to a mixed number. So then I just use division. I draw the division symbol, I put the 20 inside, now I'm going to 20 twice, which is 18. That's 2 left over. So my answer is 2 and 2/9. 2/9 is already in simplest form because 2 is prime and 3 is 3 times 3, so there is nothing to cross out. Okay.
Wait, Mr. Parker?
I will give you a few minutes to catch up before we go on. So you don't need to talk, you just need to write. Now, what I want you to do, guys, is I want you to do this work with me, because what we're going to do is we're going to do a math proof to show why when you divide, it really means the same thing as multiplying by a reciprocal. Okay, we're going to do a proof. And we're going to prove that it is true. Okay, so what I do on the smartboard, you are going to do on your whiteboard. Okay, we're first going to start with a very simple problem. We're going to just start with 6 divided by 3 equals 2. 6 divided by 3 equals 2. Now, first of all, this is an accurate division problem, correct? Now, when I take this problem, and let's say I take this and I multiply both numbers by 2. Does it change the value of this problem? Will it still equal 2? Well, let's find out. What's 6 times 2? 12. What's 3 times 2? Is 12 divided by 6 still 2?
Yes.
So it didn't change the value of my equation. Let's look at a different one. Keep the 6 divided by 3, just erase the times 2. Let's say that I multiply both of them by 3. Will my answer stay the same? Well, what's 6 times 3? 18. What's 3 times 3? 9. Does that still equal 2? So we just, in your brain, you say, I see a mathematical rule, right? Now, the rule states that if I take problems in a multiplication or division problem, and I multiply them by the same factor, or I divide them by the same factor, it doesn't change what it equals. So as long as I'm multiplying every number in it by the same factor, it doesn't change the value. Does everybody agree with me? So now that we've got that understood, erase that word. What I want us to do now is I want us to take the division part of this problem and I want to rewrite it in a different way. Now with division, we've learned that there's three basic ways to write division, right?
Yes.
We can write it this way, we can write it this way, or we can write it this way. All three of these mean the same thing. This is 6 divided by 3. This is 6 divided by 3, and this is 6 divided by 3. Does everybody understand?
Yeah.
Carlos, what is the problem? So we're going to take this problem and we're going to rewrite it in the fraction form. Do you see what I've done? This is still the same problem. This still means 6 divided by 3 equals 2. I just wrote it in a different format. That's all. Now, let's take 6/3 for a second, and let's reduce it and divide it by 3 over 3. That equals 2 over 1, which my answer is 2, correct? Do you guys agree?
Why would it be 2?
If I divide it by 3 over 3, 6 divided by 3 is 2, 3 divided by 3 is 1. Any fraction with a denominator of 1 is just the numerator. It's just 2. So this answer is correct, right? Now, so in looking at my division problem, you guys, in looking at this format, let's say that I don't want the denominator here. I want to get rid of the denominator. I want to get rid of it. Now, I just learned that if I take a number and I'm going to multiply it by something, if I multiply a whole number by its reciprocal, the number is going to be 1. So I'm going to take this and multiply it by 1/3. So I'm taking my denominator and I'm multiplying it by 1/3. So over here, let's look at that. 1/3 times 3. Now, when I'm multiplying a whole number and a fraction, I just turn the whole number into a fraction, multiply the numerators, multiply the denominators. So 1/3 times 3 equals 3 over 3, which means it equals to 1, right?
Didn't you just put them
What do you mean?
Because
what?
it's 1/3 and then 1.
No, this was a whole number, right? It's 3. To turn it into a fraction, the denominator has to be 1.
At any time?
Any whole number that we want to turn into a fraction, the denominator is 1. Right?
Yes.
Now, but you guys, remember earlier when we were needing to keep the equation the same, what did we have to do? If I multiply the second part of this equation by 1/3, what do I have to do?
I don't want to.
I'll go back up here. I said times 2 and then times 2, which was 12 divided by 6 still equals 2. What did I have to do? I multiplied both numbers by the same factor. Say it.
Multiply.
So if I'm multiplying the divisor by 1/3, what do I have to do with the dividend?
Multiply the same number.
By 1/3. So I'm going to multiply this by 1/3. Now again, this goes away because it just turns into 1, right? Any number divided by 1 is just that number. So the 1/3 goes away. So now I have a new problem. It's 6 times 1/3 equals 2. Does anybody have their aha?
You just
Oh.
divided it. You just divided it.
I just changed my division problem into a multiplication problem, and I took the second number and wrote it as its reciprocal, correct?
Wait, what?
Now 6 times 1/3, does it equal 2? Let's make sure it works. Again, turn it into a, this is 6/3. Oh, we already figured out 6/3 was 2, right? Right? Okay.
Should we practice one on our own? One more.
Erase your boards. Now we're going to actually do fractions like we were doing originally.
No.
Yeah.
Write that problem down. Guys, focus. Again, we are doing a mathematical proof to prove that multiplying by the reciprocal is really the same thing as dividing. Now, first of all, you guys, when we have a mixed number, I don't want to divide and then divide. I want to divide once. That's why we convert it into a improper fraction. So everybody multiply, then add. So that's 4 plus 3 is 7 fourths divided by 4 fifths. So I have a new problem. 7 fourths divided by 4 fifths. Write it down. Now that's the same as my original problem. 7 fourths divided by 4 fifths. Now, I can rewrite a division problem and turn it into a fraction, right? So let's take my 7 fourths, and I'm going to divide it by 4 fifths. Okay? Okay, so what don't you get, Zoe? The problem here is 7 fourths divided by 4 fifths. All I did was rewrite the same problem, but instead of using the division symbol like this, I use a fraction bar, which means divided by. This is still 7 fourths divided by 4 fifths. I just wrote it in a different way. That's all. Okay, does anybody else have any questions on that first step? Now, if I want to get rid of my denominator using a factor, I'm going to multiply it by 5 fourths. I'm going to multiply by a number's reciprocal if I want it to be equal to 1.
So wouldn't that be 20/20?
And 20/20ths is what?
10/10. Oh, one whole.
When the numerator and denominator are the same, the answer is 1, right? So this would be 7 fourths divided by 1 now, right? And what is 7 fourths divided by 1? 7 fourths. But if I want to keep my answer equal, if I multiply this by a factor of 5 fourths, what do I have to do to the other part of the problem? I have to multiply it by 5 fourths, right?
Why is it so fast?
Whatever I multiplied it by down here, I got to use the same thing up here to keep it the same.
Well, then why don't you use
Because again, remember 6 divided by 3 equals 2. I multiplied them both by the same factor, and I got 12 divided by 6, and it's still equal to 2. So if I multiply this by 5 fourths, I have to multiply the other number by the same factor.
That would be 35/16.
Now, so now let's look at this for a second. Okay, let's just look at this for a second now. The bottom part becomes 20/20ths, which is 1. So this crosses out, and this equals to 1. But this number divided by 1 is going to be just this number, right? So this really equals 7 fourths times 5 fourths, right? So I just took my division problem and I rewrote it as a multiplication problem. And notice the first number stays the same. The division sign went to multiplication, and the second number turned to its reciprocal, just like the steps teach you. So this is 35/16, correct? It's 35/16. Now, this can be rewritten as that's going to be 32, 3 left over. So that's a 3, sorry, 3 and 16. 3 is prime. Is 3 a factor of 16? No, it would be 18, right? 6 times 3 is 18, so nope. So this is in simplest form. So my answer is 2 and 3/16. So you guys, put your markers down real fast.
I didn't understand.
So the shortcut your teacher taught you last year, keep it, change it, flip it, is really all this work, but it's just a shortcut. Okay? That's why keep it, change it, flip it works. Okay, well in 5th grade, dividing by fraction is the first time you see it, so you should have learned it last year. Okay, so pay attention for a second. I want you to remember this problem now. Okay? Now,
Are we gonna do
erase your whiteboards. Okay, erase your whiteboards quickly. All right. And I need you to keep up with me here because this is where it gets hard. All right? This is where this information starts getting hard. So we had an answer of 2 and 3/16. Our original problem was 7/4 divided by 4/5. Okay? So, oops. That's not what I wanted at all.
You're so silly.
Now let's look at what division really means. Okay. I would like you to draw a 1. Just a 1.
One box.
Yeah, 1 box. I'm going to show you what division of fractions really means when you're actually dividing the fractions. Now this is really hard to get. And I'll tell you, this is the first time I've ever taught it to a group of students this way. Because this is what the Common Core is going to ask you to do. On the state test, it's going to give you this problem, and you're going to have to be able to draw it if you want to be successful. So what I'm going to ask you guys to do is, first of all, split it into fourths. Fourths. Now, because 7/4 is an improper fraction, I'm going to have to do it twice, right? Now, I'm going to color in 4 pieces here. 1, 2, 3, 4/7, or 4/4. And then I'm going to cut this one into fourths again. And then I need 4, or that's 5, 6. Now I have 7/4.
I have to go to the stage.
Just try to get someone's notes when you get back, okay? Now, what I would then like you guys to do is I would like you to take this side and I want you to split it into fifths. So basically, you need to draw 4 lines. 1, 2, 3. I'm not going to quite make it, so let me go back. So 1, 2, 3, 4. And do the same thing here. 1, 2, 3. Oops, it's still too close. So 1, 2, 3. Okay. Now, how many boxes do I have total? Well, I have 1, 2, 3, 4, and then 4, then 4, then 4, then 4. 4 and 1, 2, 3, 4, 5. That's 4 by 5. No, just in this box.
20.
20 boxes, right? So what I'm going to ask you guys to do is I would like you to draw a separate one on the side, and I want 20 boxes in it. So I need fourths, and then I need fifths. And then I'm going to color in 4 of my fifths. So since this is the fifths, 1, 2, 3, 4, 5, and it's going this way, I'm going to color in 4 of them. So that's 1, 2, 3, 4 of my fifths, right? Does everybody see it? Now, of my 20 here, how many of my 20 are 4/5?
Are your fifth?
How many of my 20 are my 4/5?
16.
16. 4 and 4, right? You guys, you just said 16. Do you notice something about our answer?
You just go lines like this.
Please pay attention. Now, so I'm going to go over here to my 7/4. Does everybody see how I colored in 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4? And I'm going to color in 16. I'm going to circle groups of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here is one group of 16. That's one group of 16. Now I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here's my second group of 16. Second group of 16. Now, how many of the 16 do I have left?
1, 2, 3, 4, 5.
There's 1 here, 1 here. No, how many are colored in?
3.
3 of
So
the
you have
16.
1 left.
So I colored 2 groups of 16. 2 groups of 16. I had 3 left over, and I'm coloring in groups of 16.
Picture frame. So basically you did 12.
I don't expect to get it the first time. Just pay attention.
I don't understand that at all.
Clap once. Clap twice. Clap. I will review the steps I did. I took 1 and I split it into 4ths because this is 4ths, right? And I know I needed to color in 7 of them. And so since this was 4ths, I could only color in 4. So I needed 5, 6, 7. Now, because this is 4/5, I took this side and I split it into 5ths. And since I had an extra one, I had to split it into 5ths. So I realized that there's 20 boxes in here. So for my 4/5, I did the same thing, but then I colored in my 4/5, and I realized that there were 16 boxes in the 4/5 out of the 20. So because I'm coloring in 16 out of the 20, I found groups of 16, and I had 3 left over. Okay. Erase this. We're going to do a little bit of an easier. Okay.
It was a hard
Erase this one. One half divided by 2/3. Write it quickly. 1/2 divided by 2/3. Draw 1. Divide it in half. Draw 1. I'm going to cut it in half. This is 1, and that's 2. Now, if I want 1/2, I'm going to color in 1 of the 2. Does that represent my 1/2?
Yes.
Now, because I'm dealing with 2 numbers, though, I need to do my 2/3 on the other side.
Yes.
So over here, I want 2/3. So I need 3 pieces. 1, 2, 3. So 1, 2, 3 pieces. I'm going to color in 2 of them. No, I'm sorry. I apologize. That will teach you. I won't get to that point. So here, in this one, how many pieces do I actually have? I have 1, 2, 3, 4, 5, 6 pieces, right? So I'm going to take another one, and this is just to see what I need to circle, and I'm going to cut it into 6 boxes again.
6?
6 boxes. It has to be the same as the first one. I want 1, 2, 3. I want 1, 2 of them, so I'm going to color in 1, 2 out of the 3. Okay. So how many boxes did I color in for the 2/3? 4 of them, right? I did 4.
Oh. Put extras on it.
Yeah, so where's my problem? I don't have 4 in here, do I?
No.
So, well, if I want to circle groups of 4 to make 1, if that represents 1 and there's 4 equal pieces, how many did I color in? 3 out of 4, which makes what fraction? Now, let's look at 1/2 divided by 2/3. You keep it, you change it, you flip it. That is equal to question.
Oh, I got this. It's easy.
Okay, I apologize. Ask your question again. Okay, you start off with your first fraction. I took a 1 and I split it in half. There's 1 piece, 2 pieces, and I colored in the first fraction. It was 1/2. Please pay attention, guys. Again, this is hard. But what I needed to do is I'm going to take this and I'm going to split it then into 2/3 also. I'm going to split this side into 2/3, just like multiplication. But I'm not going to color it in because it's not multiplication, it's division. But what I then need to do is I need to, since I figured out that this has to be 6 pieces, when I color in 2/3, I see that it's 1, 2, 3, 4 pieces. And that's going to give me my denominator. There's 4 out of the 6, that's my denominator. And then since this represents 1, I'm going to find groups of 4 here, but there wasn't a group of 4. But I know I needed 4 pieces, so there's 3 that are colored in, there's 1 that's not, so that equals 3/4. Okay, let's write everyone. Erase your boards quickly. Erase your boards quickly. Clap once. Clap once. Okay, do this with me. I first need to draw what fraction? 3/4. Very good. So I'm going to take 1, and I'm going to split it into 4 equal pieces. That's a half, and then on each side, I'm going to split it in half again. I need to color in 3 of those. That's 1, 2, 3. Now, but I need to know how many boxes there's going to be total in my problem.
8.
So I'm going to split it the other side into half. So how many total boxes do I have?
8.
So now I'm going to draw another one, and I'm going to split it into 8 pieces, which is a 1/4 by a half, and I'm going to color in the second fraction. I'm going to color in 1/2. How many is that? 4. So now I'm going to go to my fraction, my original fraction, and I'm going to circle groups of 4. So there's 1, 2, 3, 4 right there. That's going to be 1, right? Now, my second one is 1, 2 out of the 4, right? There's 2 out of the 4, correct?
So 1 and 2, 4.
So what is my answer going to be? 1 and 2/4, but then 2/4 can be reduced to what? 1 and 1/2. So I'm saying that this equals 1 and 1/2. So let's try, you guys. 3/4 divided by 1/2. You keep it, you change it, you flip it, which is 6/4. 1 and 2/4, which we divided by 2/2, which equals 1 and 1/2.
Why can't you do it that way with So what's the answer, Mr. Pepper?
Okay, again, I've already explained this to you. The Common Core doesn't care about keep, change, flip. They care that you understand what you're doing when you're dividing by fractions.
Mr. Pepper.
Clap once. Clap twice. Clap two times. Look up here at this problem, everybody. This is saying to you that when I take 3/4 and I divide it into groups of 1/2, my 1/2 has to be 4 equal pieces out of the total of 8 pieces. So I'm dividing it into groups of 4. So here there's 1, 2, 3, 4. That makes a 1, right? But here there's 1, 2 out of the 4 because there's nothing on my last 2 pieces. Which means there's 1 and 2/4, and then 2/4 we see that this is also 1/2, right? It's the equivalent of 1/2. Because these 4 pieces I could just split it into 2, and that one of them is colored in to make 1/2. You know, I'll let those that think they're ready try it by themselves, but I can tell a whole bunch of you don't know what you're doing yet. And that's okay. Once I've divided my first fraction into 3/4, I divide it by the half also, by the second number, and then I count how many boxes I have. And then I just do this on the side to figure out how many boxes I need to color in. So I do this one, I make it exactly the same, but then I'm coloring in the 1/2. There's one, this is 1 piece, and this is 2 pieces, right? I color in 1/2 because that's my second number, and I color in one of the 2 pieces, and I see there's 1, 2, 3, 4 boxes that I colored in. All I'm doing is copying this to figure out how many groups I need to circle. Okay, yes?
When you switch it together, 3/4 and 2/1, can you already just switch it?
This is the algorithm we learned last year, and I'm just checking my answer to make sure it's right. Again, on the state test, you guys, you're not going to get this. It's not going to say what is 3/4 divided by 1/2. It's going to say draw a picture that clearly demonstrates dividing these fractions. That's what it's going to say. Yes. How many boxes here? I have to box 4 of the 8 to make a 1, in this case. All right, let's go. Try this one on your own. Five sixths divided by 1/3. Okay. The algorithm on this. That's what your answer should be.
Huh? Oh, okay. We're trying to do this. We do this problem.
Your answer should equal 2.5.
Oh, we're supposed to do it by ourselves?
Okay. So step number 1, draw 1 and make 5 sixths. So if you do thirds, and then you cut the thirds in half, that will give you sixths. And I need to color in 5 of them. But then to figure out how many boxes I need to go to the other side, and I need to cut it into thirds. And how many total boxes do I have?
1, 2, 3, 4, 3, 6, 9, 12,
I have 18
15.
total boxes, right? So if I have 18 total boxes, now to figure out how many I need to color in, I'm going to make the 18 boxes again. So again, I'm going to do thirds. I'm going to cut the thirds in half to make 6. I'm going to do thirds. And I'm going to color in 1/3.
I did too.
If I color in 1/3, how many boxes did I color in? 6. So I need to circle boxes of 6. Now my denominator is going to be 6 here. So here I have 1, 2, 3, 4, 5, 6. That's one group. 1, 2, 3, 4, 5, 6. That's 2 groups. Then I have 1, 2, 3. So I have 2 and 3/6, right? But 3/6 can be reduced to what?
2 1/2. Mr. Tucker?
3 divided by 3 is 1, 6 divided by 3 is 2.
Mr. Tucker, I need extra supportive help.
Now, some of you probably are going to start seeing a pattern. Okay? There's a couple steps you can skip here to make it a little bit easier.
Yes. I want
Yeah, raise your boards. Let's try another one. Did you pay her? Did you pay her?
I think it's
Carlos was like, kid was back. Stop once. Clap twice. Okay. It's saying I want circled groups of 1/4 in the 2/3. If I circle 1, 2, 3, if I circle 3 pieces here, 1, 2, 3 pieces out of the total number, which is 12, what is that fraction that I circled? What is 3/12 reduced to its simplest form?
1/4.
I circled 1/4 of my shape, or of my hole. So the reason I'm circling 3 is because 3 out of the total 12 is my 1/4. 3 out of my total of 12 is my 1/4. Okay? Do you guys understand?
Yes. How did you get 3 3?
I reduced it to its simplest form. 3 is the GCF here. I divided by 3 divided by 3 to get 1/4. I did the GCF work in my brain. Found a common factor. Yes? All right, so I'm going to stop that because that's already on the tape. Pay attention. We have 3 minutes until lunch. Okay, you guys. Here, after we split up our 1, we had 20 pieces, correct? 4 and 5, which makes 20. If I look back at my original problem, right? For my 3/4, I had 3, 6, 9, 12, 15 pieces colored in, right? For my 1/5, I'm coloring in 1, 2, 3, 4 of the pieces. Mathematically, what am I really doing by drawing this picture? I'm taking this 5 and I'm multiplying it over here, right? I'm taking this 4 and I'm multiplying it over here. So I have 15/20 divided by 4/20. Pay attention to this. I am circling groups of 4, so really what I'm doing is I'm taking 15 divided by 4, correct? So 15 divided by 4 is going to be my 3 3/4. Because what I'm doing is if I split it into equal number of pieces, it makes the division very easy. Because then I'm just dividing the denominators, which just equal 1. Right? So 15 divided by 4, that's going to equal 3 with a remainder of what? And because I'm dividing into groups of 4, it's 3 out of the 4, so it's 3 3/4. That's why this works. I need you to connect this. Once I have equal number of pieces, I'm just dividing the numerators, and that's it. Anybody have any questions before we go to lunch?
No.
Clean up, get ready to go to lunch.